This is Mastering Mathematics with your teacher, Karen Weston.
Hello, here we are again. This week we are on our second edition of Mastering Mathematics, program produced by the Antigua and Barbuda Ministry of Education Broadcasting Unit in conjunction with ABS Television. I told you mathematics is going to be a doorstep experience for you and a bedroom one, and I'm sure you can feel the vibes already. Well, last week we left you and we told you that we have names of numbers. So you were talking about whole numbers, prime numbers, composite numbers, even numbers, cardinal numbers, ordinal numbers, odd numbers, Roman numerals. Today, we may not be touching all of them because I have to introduce to you the policeman who is in charge of all the operation we told you about when you said we had to do bomb das. You remember that? We have to get our brackets first, then of, multiplication or division, addition and subtraction. Guess what? There are laws governing these things, and I will now introduce you to some of those laws governing the operation of these things. The first one I want to talk about is commutative law. For us in mathematics, this is what is happening. Every time we have to multiply numbers, there has to be something governing it. The law says it does not matter the order in which we group or multiply our numbers. So that if we had to multiply 2 by 3, we should get the same answer as 3 times 2. And we all know that that will be 6. That is a law, and that has to be observed. Again, it says the order in which we add numbers does not matter. So that again, we could have said 5 plus 8 is the same thing as 8 plus 5, which is equal to 13. That is what policeman commutatives has to tell us about our mathematics operation. Then you are aware that there are at least 4 basic operations for mathematics. So we have multiplication, division, addition, and subtraction. The law does not hold for subtraction. So for example, eight minus 5 is not the same thing as 5 minus 8. Neither does it hold for division. So that if we had to say 4 divided by 2, it is not the same as 2 divided by 4. So that our commutative law works only for addition and multiplication. We get next to the second policeman, and it is the associative law. And it says the associative law this time we are expanding our operation, because everything like human nature, once we try something and you say, let's go a little further and a little further. So this is what we do. It's distinguished by saying you can have 3 plus 2, and it is plus 5, and it would be equal to 3 outside the bracket plus, in bracket, 2 plus 5. And what it is the law says the way in which we add numbers in groups of 2's does not affect the sum. So we group them in the bracket here, 3 plus 2, and we're working out bracket first. So we would have been getting 5, and then adding 5 to it would give us the same result as if we had to say 3, work out bracket first, plus, and it is 7, and of course we will be getting 10. So the way in which we group numbers in 2's does not affect the sum. It works also for multiplication, and says the way in which we multiply numbers in groups of 2's does not affect the product. We can take a break now, then I'll be right back.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at the problem, you may misunderstand what really needs to be done to solve the problem.
In terms of multiplication, our associative law operates along the same pattern as the addition. We can have 2 times 3 in a bracket multiplied by 4, and that would be equal to 2 outside the bracket times open bracket, and it would be 3 times 4. And we know right away 2 3s would give us 6. Working our brackets first, we're going to get 12 here, and then it is plus 4, and it would be equal to, 2 times 12 times, and then we're saying 6 times 4 would give us 24, and 2 times 12 would give us 24. So again, the order in which we, in groups of 2s, put our numbers and the operation, we will get the same answer. Once again, for the same reason as exhibited before in commutative law, it does not work for our division nor for our subtraction. Try that and tell me if I am true, or if you got the same answer, or if you want me to come and say, Miss Weston, how did you tell me this and it did not work? That is our commutative and our associative law. Now, there is a law, and we don't have to kill you too much with them, but the law for closure, that is going to bring us into another aspect of our mathematics that we talk about, which is always heading of number theory. Because I started talking about the different kinds of numbers, whole numbers, etc. Let us start giving you some of them and telling you how you would identify them. Especially for those people taking the CXC results, they can ask you which one of these would represent the set of whole numbers, which one would represent the set of irrational numbers, and that is what I'm going to be doing right now, and making certain that in the process I too do not make any mistake for that. The first one we want to talk about, and which is usually number 1, is the natural numbers. And notice, because you're going to see what distinguishes certain numbers would just be the members that we would have in our brackets. Here we have, and this is what we get when we start our primary school all the time. You're saying, I can count, you know. And you say, count for me then. And you start 1, 2, 3. When they start that way, they're actually in the family of natural numbers. So if we see in our brackets, represented by n, and is equal to our set, and it is 1, 2, 3, right up, and we can go right up to infinity, that will be our set of natural numbers. And then somebody says, uh-oh, you're forgetting another number that I know exists in the realms of mathematics, and that is our 0. So where does it fit in? So if we start counting from with 0, we would be going 0, 1, 2, 3, and going right up again to our infinity, and that would be the set of whole numbers. Look at the difference between our natural numbers and the whole numbers is that our whole numbers has an additional member, which is 0. After that, we can start talking about other numbers, and let us take you into the realm where we'll be talking about integers. All right, this time we're still saying, are there more numbers for us to know about? And I told you last week about counting numbers and started saying these are the things that make us have difficulty in terms of mathematics. And I gave you 0, 1, 2, 3, 4, and we went right up to 9. But like everything in nature, there is always a reaction and an alternative to whatever we are doing. Okay, so every number that I gave you last week, a positive, there is a negative brother to it, and it is called a negative number. Okay, so I could have stretched that number line, and instead of going from just left to right, we can expand the whole plane, and so 0 would be our anchor, and we would have 0 and going in this direction, and we're going here, and I had invited you to come and say we're going all the time from left to right, where you're getting into your positive numbers, and then so you'd have been going, so we have our 0. We have our 0. Now today, because I'm on this board, let's do it properly. I'm going here that on this direction, it would have been 1, 2, 3, 4, which would be in our positive direction. And coming in this direction here, it would be our negative numbers, which is going -1, -2, -3, right up to negative infinity. I want to get it right today in this direction, because when you're doing your axes, which is going to come very soon, you're going to see right away that when you put it in your books, where your positive numbers come. All right, so this is what it's going to be. So our 0 always acts as the beginning, and if we're walking in this direction, we're going in our positive direction. This is in our negative direction, and so we do have negative and positive numbers. When we have that, and with 0 in it, it is called the set of integers. So that when you get to your bracket, you're going to get Z, and it's going to be getting in here. So you have negative infinity, and you're going -3, -2, -1, 0, and then we're going 1, 2, 3 in that direction, and we can get the whole set of integers. We also have some numbers, and there would be like what you would be calling specific numbers, okay? And we talk about rational number, and you want to ask, what is a rational number? And easily you can say decimal numbers are called rational numbers or fractions. So we can take a break now so that you can absorb all this, then we'll be right back.
Be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so that all your values are in the same unit of measure. For example, change all values to feet. When asked to show work or justify your answer, don't be lazy. Write down everything about the problem, including the work you did on your calculator. Include diagrams, calculations, equations, and explanations written in complete sentences. Now is the time to show off what you really can do with this problem.
As we know, when we talk about fractions, we are talking about a number. So we have R, the set of rational numbers, and just for thing, we'd have a numerator, and it's over a denominator, and where D would not be equal to 0, but would be a member of our integers, okay? So it can be belonging to the set of integers, and that is what we call our rational numbers. So that, for example, a half would be regarded as a rational number, 2 upon 3, even over 9 over 4. All these would be regarded as rational numbers. Again, sometimes we can write our rational numbers as decimals, because we know once we get into the avenue where we're dealing with denominators as powers of 10, you'll be more or less saying sometimes you're translating them into decimal numbers. And so we tell our students, if you have 5 over 10, that would be equal to 0.5. Or if we have 20 over 100 again, that would be equal to 0.2. All right, and that is what we're talking about in terms of saying we can have them, and it does not have to be powers of 10. Any number you're dividing and you're going to get decimal numbers coming out of it, that would also be called a rational number. We enter then into the realms of irrational numbers, and we say any number where we cannot take the exact square root of that number is called, and where the answer is not a whole number, is called a irrational